Hi. In the last lecture, we were discussing about process synchronization, and I told you about race condition. And in order to avoid race condition, we need to implement process synchronization. And also, I told you about critical section, and also at the end, I said that in order to successfully implement process synchronization, several factors have to be considered. Okay. So in this lecture, I will discuss about the requirements of the process synchronization. Means in order to successfully implement the process synchronization technique, what are the requirements that we have to consider? Okay. So let's see here. Requirements of process synchronization. The first one is mutual exclusion, then progress, then bounded weight, then architectural neutrality. Okay. So let me discuss it one by one. So what is mutual exclusion? Mutual exclusion means what? Uh, According to the principle of mutual exclusion, you see, suppose there are two processes, okay, and if one process is using a shared resource, okay, if one process is using a shared resource, then other process is not allowed to use that particular shared resource which is being used by another process. Okay, so it's totally based on the principle of mutual exclusion. For example, you see here, there's a critical section. Okay, there's a critical section. CS means what? Critical section. Okay, so what I told you about the critical section, it is a region where the shared resources are accessed. Okay, so suppose there are two processes. Although lots of processes can access the shared region, but for the sake of simplicity, I am giving the example of just two processes. Okay, so suppose both these processes want to enter into the critical section. Why they want to enter into the critical section? Because critical section contains shared resources. Okay, critical section contains resources which should be accessed by both P1 and P2. So in order to access those resources, both these processes wants to enter inside the critical section. Okay, so suppose P1 entered inside the critical section. Okay, P1 here I am writing CS. Suppose P1 entered inside the critical section. So P1 is here. Okay, P1 is here, and P2 also want to enter inside the critical section, but since mutual exclusion is there, so only one process can be inside the critical section at a time. Okay, so this is called mutual exclusion. What does mutual exclusion do? When one process is already inside the critical section, it doesn't let other process to enter inside the critical section. It means what? If P1 is inside the critical section, P2 can't enter inside it. Okay, P2 can only enter inside the critical section once P1 comes out of the critical section. Okay, once P1 comes out the critical section, then only P2 can enter inside it. Okay, for example, you see, there are lots of examples, daily life examples are there, like the trial room in the mall, or you see washroom. Washroom is a very good example. So generally what happens there, when one person is using the washroom, then what he will do? He will just lock the door so that other person cannot enter in that washroom which is being used by him. Okay, so same thing is happening here. So how the things are how the things are happening, if the critical section is empty, then the process can enter inside the critical section. For example, you see that here the critical section is empty. Okay, so now you see this entry section will allow P1 to enter in it. this entry section will allow P1 to enter in it. Now you see P1 is inside the critical section. Okay. And suppose when P2 wants to enter, what I told you, that the entry section code is written in such a way that it will allow the process to enter inside the critical section only if the critical section is vacant. So, okay. Now when P2 wants to enter, definitely it will also have to go through this entry section. But since critical section is not vacant, process P1 is already present inside the critical section, so P2 will be blocked. Okay, P2 will not be able to enter inside the critical section. So this is all about mutual exclusion. Okay, the codes are written in such a way that the entry section codes are written in such a way that it will allow only one process to enter inside the critical section. Okay. And also suppose, then how P2 will enter inside the critical section? When P1 will come out of the critical section, then P2 will enter. So here you see, now in order to come out of the critical section, P1 will go through this exit section, and after that P1 is here. It means what? P1 came out of this critical section. Fine. And now you see the critical section is vacant. Now P2 wants to enter. So P2 goes through this entry section, and what I told you, since the critical section is vacant, so the code of the entry section will let the process P2 to enter inside it. So this is all about mutual exclusion. And the next point is progress. It's also very important. You see what is progress. So I'm not giving you any formal definition, because you can find the formal definition in books and also in the internet, okay, in the Google. Okay, so just what I am telling you is just for your concept building, because in order to solve the numericals or theoretical questions, you have to clearly, you should have a good idea of all these things that I am discussing. So just please watch, please listen very carefully. Okay, so the second point is progress. Okay, so let me discuss about this. What is progress? Progress means what? You see, suppose it's a critical section. It's a critical section, and maybe suppose two processes are there. And I am telling you again and again that it's not necessary that only two processes should be there. More than one process, multiple processes may be there. Okay, but just for the sake of simplicity, I am giving the example with two processes. Okay, and suppose process P1 wants to enter inside the critical section. Okay, process P1 wants to enter inside the critical section, and definitely process P1 can enter inside the critical section. Okay, because the critical section is vacant. But you see, sometimes it may happen that process P1 wants to enter inside the critical section, and maybe process P2 doesn't want to enter inside the critical section. Okay, but process P2 himself is not interested to enter inside the critical section, but it will also not let other process to enter inside the critical section. Are you getting it? I mean to say that, you see here, process P1 desires to get inside this room. Okay, and now process P2 has no interest, but although it has no interest, but it will also not let process P1 to enter inside it. It means what? It has no interest to enter, it will not enter. So it will not enter, and it will also not let others to enter. Okay, it's like that. You see, in our society, what happens? You will find most of the peoples, they will not grow. Okay, and also they will not let others to grow. Okay, due to jealous, all these things. Okay, so That's the main problem here. So if these things are happen, then we will say that progress is violated. There is no progress at all, because progress means what? Although if process P2 is not interested to enter inside the critical section, okay, but it will not stop process P1 to enter inside the critical section. Since process P1 is interested, so process P1 can enter. Okay. And also, I mean to say that at any time, one process should enter inside the critical section, either P1 or P2. The uninterested process, which is not interested at all, should not block the other process to enter inside the critical section. Fine. So that's about progress. It will be more clear when I will teach you the further log variable, then turn variable. Okay. So now let's come to the third point, bounded weighting. So what here bounded weight means what? Here there should be bound. There should be a limit on the weighting of the process to enter inside the critical section. For example, you see, suppose there are two processes. Okay, process P1 entered inside the critical section. Okay, process P1 came out. After that, process P1, okay, like this. Process P1 is here now. Now process P1 entered inside the critical section. Okay, and now process P1 came out. Okay, again process P1 entered inside the critical section. Again process P1 came out. Again process P1 entered inside the critical section. Process P1 came out. So you see, here process P2 is also interested, but it cannot enter inside the critical section. It just keep on waiting. And you see, whereas process P1 is entering into the critical section again and again. So here there is no bounded waiting at all. Okay, because maybe process P1 entered the critical section, you see, 100 times. Okay, and till 100 times process P2 had to wait. So you see, there is no bounded waiting at all, because P2 has to wait infinitely, because you see P1 is keep entering into the critical section again and again. So there is no limit on the number of wait for process P2. So this is called bounded waiting. So bounded waiting means what? Each process should have a limited weight. Limited weight means what? When P1 is entering inside the critical section, okay, and P2 is waiting, and when P1 comes out, after that P2 should enter inside the critical section. It should not be the case that P2 should wait indefinitely to enter inside the critical section. Okay, there should be a limit to wait. Okay, and the fourth one is architectural neutrality. Okay, so what is architectural neutrality? It means what? It's regarding platform independency and dependency. You see, there are different types of process synchronization techniques. Okay, so some process synchronization techniques, they need the support from the operating system. It means what? In only in some particular operating system, these program can run. Okay, so that's about architectural neutrality. It also there are some process synchronization techniques. They are architectural independent. It means what? They doesn't depend upon the operating system. They don't need any operating system support. They can run in any machine. Okay, and also there are some process synchronization techniques which only run on particular operating system, as they need support from the operating system. Okay, so that's all about process synchronization, the requirements of process synchronization. Okay, so Also, one important point is left. I tell you, busy waiting. Here I should write busy waiting. Okay. One thing I want to tell you that these first 2 points, mutual exclusion and progress, are the primary importance. Okay. These are primary requirements of process synchronization. It means what? In order to successfully implement process synchronization, at least these two steps, these two requirements, mutual exclusion and progress, have to be satisfied in order to successfully implement process synchronization. And rest 3 and 4, these are secondary. Even these 3 and 4 are not satisfied, but 1 and 2 are satisfied, then we can call it as a successful process synchronization. Okay. And you see, and the 5th one is busy waiting. So what is busy waiting? Busy waiting means what? I tell you, suppose when process P1 is inside the critical section, okay, and process P2 is waiting to enter inside the critical section, okay. So maybe process P1 may take some amount of time in order to come out of the critical section, because before it comes out of the critical section, it will have to perform some task inside the critical section. So it may take some time. Okay. So P2 will wait for that time. So rather than waiting outside the critical section, it should go and do some other useful task. Okay. For example, just take an example of washroom. Okay. You are inside the washroom. Okay. You have locked the door and another person is outside. Okay. Then he will just continuously knocking the door. So this is called busy waiting. So it's better he should go and do other tasks. Okay. Rather than just knocking the door, he should go and do other tasks, and when your task is finished and when you come out of the washroom, after that he will come inside the washroom. Okay. I think washroom is not a suitable example because it's an emergency case. Okay. If one feels emergency, then how he will go and do other tasks. Okay. So okay, but I think you got it, what I wanted to tell you. Okay. It means what? Here you see, when process P1 is inside the critical section, okay, process P2 is continuously knocking the door of the critical section. Okay. I want to enter. Okay. So it's simply wasting its energy. So rather than continuously knocking the door, he should go to somewhere else and do some other task. And when it will come out of it, then after that, P2 will enter inside the critical section. So knocking the door continuously is busy waiting. Here simply a CPU cycle is getting wasted. Okay. So these are 5 important points of critical section process synchronization 1 and 2. Point number 1, mutual exclusion, and point number 2, progress. These 2 points are very important. And rest 3 points, bounded waiting, architectural neutrality, and busy waiting. These are of secondary importance. Okay. Now after this lecture, I will tell you about log variable. Okay. Thank you.